Hello everyone. In this short video, I'm going to show you how to calculate the correlation that exists between quantitative variables. Just to be a bit more specific here, correlations are appropriate when comparing or looking at the alignment that exists between two quantitative variables. Whether they are discrete or continuous makes no difference. Both are acceptable. And a correlation is also acceptable when comparing a quantitative variable with a binary variable. And we'll see one of those in this current file. So I've got a data set in front of me here that consists of prices for a sample of homes, as well as different characteristics that are associated to this home. So the area, so the livable space, the number of rooms, bathrooms, the acres over which the house is built. The variable metro is a binary variable that simply means that that is coded by a 1 if the home is within 2 kilometers of a metro station and 0 otherwise. Fuel and exterior are qualitative variables. In the case of fuel, it would be a nominal variable or a categorical variable. Exterior is an ordinal variable because we see how there's a certain ranking of the exterior condition. Now, I guess the shortcut key, if you simply want to calculate the correlation between two variables directly, would be to place yourself in any empty cell. So as you can see, I'm in cell J2 right now on the right-hand side of the screen. All calculations can be started with an equal sign. And as I may have discussed in the past, if you're intuitive about the function's name, you may well just try to type the first letters of the function. So notice I'm starting to write the word correlation, and already options show up, among which is correl, which is a correlation between variables. So double click, and Excel is asking you to supply two arrays. So essentially the two columns under which or in which the data is found for the variables that you are correlating or that you are trying to measure the correlation. So for instance, I'm going to select all of the data under variable price. Okay, we have to place a comma to separate the two sets of data or the two arrays, and then I'm going to correlate or measure the correlation with area. So I'm selecting all of the data under area. I've closed off my parentheses in the function, but most times Excel will forgive you if you simply type enter right away without closing the parentheses itself. It'll understand that you're done inserting the operation. If I click OK, then the outcome of the correlation is given in the cell where I wrote the formula. In this case, 0.696, which is a relatively high correlation coefficient. Simply means, by the sign in this case, that overall, as the area tends to grow, or as the area of a home grows, the price will always will have a tendency to grow as well. Okay, so not a surprising outcome in this case. I could also have calculated the correlation between price and metro, for instance. So if I select the data for price, and then I have to separate my arrays with a comma, and metro, after which I'm closing my parentheses. If I press enter this time, the correlation that we're getting is slightly negative, and notice that it's extremely small. So essentially here what we're observing is that there is no linear trend, or very, very little linear trend between price and metro. In other words, there doesn't seem to be a very strong, at least linear association between the fact of residing near a metro station and the effect it might have on the price of the home. So this is one way to calculate correlations for pairs of variables directly. However, if you want to compare correlations for all combinations of the variables that appear, again disregarding the categorical and the ordinal variables on the extreme right, then you can also proceed through the data analysis toolpack. So I still have my data in front of me. I'm going to access data, and if you go through data analysis, then you can actually ask for the correlation and tell Excel where all of the variables are located. And this time, contrary to what I did earlier, you can even incorporate the labels. So I've selected all of the data for the quantitative and binary variables that appear in this file, and I'm going to specify that that my selection did include the labels at the top. By default, Excel will offer you to put the correlation table in a new worksheet, and that's fine. I'll say OK. Now notice how there is pretty distinct advantage to doing what we just did. This time we have the correlation for all the variables. I think the highest correlation that we see in size, so not necessarily in sign, is the 0.8296. So a correlation that is relatively close to being equal to 1. And not surprisingly, it's between variables rooms and area. Makes perfect sense that as the number of rooms in a home increases, the tendency will be for this house's area to also grow. It'll take up more living space. Kind of coincidentally, Metro is the only variable that had a negative correlation with price. Again, we're talking about very, very small numbers here, and because data is provided from a sample, probably we cannot make really any conclusions about such a relationship. These are things that we'll discuss later on when we talk about hypothesis testing. And there you go, 2 quick ways of calculating correlations among qualitative/binary variables. Saying goodbye for now, and see you soon.